All right, welcome everyone. I'm super excited to be here. As said, I'm Louis-Etienne from Ticketmaster, and I'm going to talk to you about deploy, scale, and extend Jaeger. So here's the agenda for today. As you'll see, it follows the title of the talk pretty closely, so I hope you're not too surprised. This talk will indeed focus on Jaeger and what we've learned along the way using it. At Ticketmaster, our mission is to power unforgettable moments of joy, and to realize this, we need to make sure our systems are behaving and functioning correctly when you interact with them. Those of you who already use Ticketmaster before might recognize this screen. It's our website, more specifically our seating chart. That's what you use to buy tickets. Sounds simple, right? You click, you pay for it, and you wait for the show. There's actually some quite unique challenge in the ticketing industry, and that includes the fact that every single product we sell are unique and carefully picked by our customer. So it's obvious that we don't want to sell the same seat twice and have you share your seat with someone else. All that we have to ensure all that while handling huge amounts of load that could be similar to a Black Friday. But there's at least one other time you interact with Ticketmaster that you might not know or realize as much as buying the tickets online, and that's when you enter the venue during the day of the concert of your favorite artist or sports team. When the validation is done, it's done by our system, and no matter how you got your tickets from our mobile application to a real paper ticket, that validation goes through our system. And to ensure that everything works fine even at that scale, we have some additional constraint being a 40-year-old company, and we've been innovating for all these years. So internally, we have not one, but 27 ticketing systems that are backed by more than 300 products. Our internal cloud includes more than 20,000 VM in 7 data centers. And because we're at KubeCon, I felt that the last stats was mandatory. So we're at 15 Kubernetes clusters right now. All those compute power and those infrastructure are used to power services from all the language shown here. There's probably much more. I probably can't fit all that, but those are the biggest one. But it also serves to power one of our ticketing systems that's a VAX program. And if you don't have a computer like that on your desk, you can also run it on Minikube nowadays. So listening to me talking about all that should already tell you the answer to the why tracing question. And I won't really go into all those questions. So what is tracing, how to do tracing, and even why do tracing. There's already some great talks about that. Some very great presenter did that in various conferences, but I've linked 4 talk that resonate with me in the last two years. Yeah, the last 2 years. So I recommend, if you haven't watched those, to listen to them. They all been recorded and they are available now. Well, after the talk. There's still one reason that wasn't mentioned in all those talks, and that was one of my reasons to do that. And it was to prevent people from searching log with 20 long line, 20 with a query that long in any search engine. It's not meant to do that. It can be forced to do something like that, and we've done it, but that's far from what you should do. And to achieve that, we've used Jaeger. I'd say it's been a fun ride getting to where we're at now. So let's get started. Before we talk about Jaeger, this is our current state. We have 25 services instrumented, a little bit more than that in non-production. We use the Java, Node.js, the Go client heavily, and we're starting to see people using the C# and some C++ via Envoy as well. Even with sampling, all those services push up to 9,000 spans per second. We keep about 5 days of data, which adds up to 2.1 billion spans in Elasticsearch, or that could be translated to 1.2 terabyte of data. So while Jaeger is used in production at Ticketmaster, it's far from being rolled out everywhere. So that's not a cluster as big as what you would expect from Uber or even some other people I've seen on GitHub. But I still felt that sharing the actual numbers will help the community get a feel of what it can do. So how did we start this effort? How did we grow adoption internally? I'd say the main advice I could give you is to start with the development teams. Before switching to the ops side, I was a Java developer working on various API, and I can really tell you that tracing does fill a gap between logging and metrics. Working with them is the best way to get started, and you'll see that they care about it, and that it's something they will want to do. Usually we start with a demo with the team, followed up by a Q&A session, and generally the first question is, how can I get started? So try to understand what language, what framework you use internally. There's multiple questions on that slide. Try to answer these. It's going to be what you'll be working with from now on. Internally, we have we have a service template that was used heavily to seed new project, so that helped gaining traction at first, to instrument this. And once you're done with the instrumentation, or at least have started that, the infrastructure is one thing, but you'll also have to do documentation. It's not the funniest part, it's not always enjoyable, but it's going to save you quite some time down the road as you scale from one team to much more. Try to answer these questions in your documentation. That's what we did, and people were finding that helpful. But also, if you see a question being asked over and over, that's probably a good indication that your documentation does not mention anything about that. And all that won't happen overnight. I don't think you'll be able to find all frameworks that your company use, or even guess or find every piece of documentation you should write about it. So start somewhere. Try by working with your first team, instrument the bare minimum framework, and that might look harder than it really is, because there's already a good coverage on the opentracing.io registry, and that's open source instrumentation for various projects from Java to Python to Scala, and a lot of these. I talk about documenting how to use them. Usually the open source project already mentioned that, but we found that some little piece of our service template required additional documentation, so we've mostly focused on that and linked to the open source documentation for more. And you'll have eventually to start testing that instrumentation. You might find a team that's willing to do that with you, but we've usually started by sending PRs directly to the team. And the process of doing the first PR, you'll usually find the most obvious problem, so fix these. After that, have them deploy it somewhere because a non-merge PR doesn't get you anywhere closer to where you want to be. Having it at prod does validate some things, including a network ACL or deployment script. So that's very important. And once that's in production, you fix most of the issues you could find. Repeat that with another team over and over. Once you've done that a few times, we started to see people reaching out directly instead of us sending pull requests. They heard about it from other teams. They wanted to know more, but most importantly, people that onboarded tracing wanted to know more about those black box and those long span calling and other services. And they started asking other teams and pushing them toward having tracing as well. So that's really a snowball effect we notice. Your documentation will start to be ND at this point. We've started with 1 or 2 teams and scaling to 55. The last 30 were at a very rapid rate. So that helped. And always continue to be involved with the teams. There are going to be new problems, try to fix them, and always try to orient them to open source solution and contributing to in GitHub as well instead of forking internally. So let's move on how we deployed Jaeger. This is the architecture diagram of Jaeger. I'll walk you through it quickly. If you've never seen that before, it's part of the official documentation. On the left, there's a gray box, which kind of looks pink here from my angle. It's your host or your VM, your Docker container. In that gray box, you see the yellow box being your already deployed application, something that you already have. Everything below that, the tree block below that will be the new code you'll add to instrument your project. That includes the various instrumentation framework, the Open Tracing API, and the Jaeger client that implements that API. If you look at the bottom of the gray pinkish box, there's the Jaeger agent that runs alongside of your application. It's a separate process, and it handles taking those spans from your application and sending that to the collector. The collector is in the middle. Its job is to save those batch of span it received from all your clients into your data store. The data store being the green box at the bottom. There's now 3 implementations of the data store in which is Elasticsearch, Cassandra, and newly Badger that was just released in 1.12. If you look on the right side, there's the Jaeger UI and the Jaeger query, which are usually deployed together and are used to visualize what's in the data store. If you already looked at the documentation, this might be new. It wasn't, well, it's still not there yet. It's an alternative way to deploy Jaeger. The main difference being that the Jaeger collector will write to a stream instead of directly to the data store. The stream currently can only be Kafka. That could be extended at some point. Once the information lands in Kafka, there's a new component called the Jaeger ingester that reads all the data from Kafka and sends that to the data store. Kafka being able to handle much easily spikes of traffic than something like Elasticsearch. We use that to have a constant flow of data going to Elasticsearch and not overwhelm it. The rest stays the same. The query and the UI are deployed together. They query the data store, and your agents still only talk to your collector. We have 3 different environments deployed in Ticketmaster. We have the non-production, the pre-production, which could be named staging, and the production one. It's important to note that every application that talks to one that talks one to the other needs to share the same Jaeger cluster. If they don't share the same, the trace won't be connected together and you won't be able to view them. We decided to use Elasticsearch, as I said earlier. We don't run it inside Kubernetes because we wanted to save time and focus on Jaeger instead of Elasticsearch. But everything else that's marked with the Kubernetes logo is deployed in our Kubernetes cluster. So that's the Jaeger collector, the Jaeger ingester, and the query as well. The architecture of Jaeger makes it super simple to deploy that in Kubernetes because all those 3 components are stateless, so they don't have a state on disk. Internally, we have a custom Helm chart, but it's just a deployment object with some templating on top of it for all 3 components. We also use a cron job object for the Elasticsearch Index Cleaner, which is self-explanatory. We clean index every 5 days, so that runs in the cron job. And the Spark dependency, which is another component that aggregates all your data and creates the map of services, what talks to the other. Regarding load balancing, the Jaeger collector receives both HTTP and TCP, various TCP protocol. So we use a service with type load balancer to expose it externally from the cluster. There's also an internal endpoint to save some network round trip. In AWS, which is where we deploy currently, it translates to an ELB. As for the Jaeger query, we use an ingress resource because it's all HTTP. In our case, it's an ALB ingress. All right, so the last component of the Jaeger infrastructure is the Jaeger agent. There's 2 different ways to deploy it. There's the daemon set way and the sidecar way. The sidecar one is deployed alongside your application. So for every application you deploy, there's a Jaeger agent. And the second one being a daemon on your instance. So multiple applications share a single Jaeger agent. The initial design of the agent was to run as a daemon, but there's some trade-off. In fact, the pros and cons of the sidecar and daemon are inverted if you pick one to the other. With the sidecar, you get better isolation. This means that if you have a bad client that's sending too much traces, for some reason, it cannot affect another client. The second one being security. You don't have to punch a hole in your network to send UDP packets across to the same agents. Those are fully isolated and they talk one to the other. That comes with additional resource utilization. You'll have to run one, and you'll have to load and run one Jaeger agent per application. And there's some additional complexity that I'll talk just after if you're not inside Kubernetes and you're doing the sidecar. The resource utilization is the biggest pros of the daemon set. You essentially just deploy it once per host, and everything talks to it. There's some additional complexity if you're inside Kubernetes, which is in the pros section for some reason. It's not. And the isolation is slightly, is not as best as the sidecar because there's multiple clients that can affect each other. The added complexity I was referring to is that by default, the Jaeger client by default, it reports to localhost, and it's not always the case if you're using Docker run with --link. It's going to be a different host name than localhost. And the same goes for the daemon set approach in Kubernetes. It's not going to be localhost, it's going to be the IP address of your worker node. So you'll have to set those two variables in the first section. And to make it even harder, the second one does not have the same format for every language. So you've been warned. There's now a Jaeger operator for Kubernetes that abstracts all that. They support various deployment strategy from all-in-one being kind of developer mode, trying it out easily. The production one being the first diagram I showed earlier, so there's no Kafka involved. It could run Elasticsearch or Cassandra with that. And with the streaming approach, you have basically the same deployment as we do internally, but with much easier config. It also supports both Jaeger agent strategy, so you're not stuck with using either one. It can even inject the sidecar for you in your deployment, so that's a very good, a very nice thing to have. There's the new version support version upgrade for Jaeger, so that's one of the things we were missing before we were using that. So all that is easy if you have only a single region, but in our case we have multiple, and you probably have multiple regions as well. There's various ways you could do that, from having a Cassandra cluster that spans multiple regions. But in our case, we decided to use Kafka and a replicator, a message replicator for that. In this diagram, the red arrow means we're writing to Kafka, and the blue arrow means we're reading from Kafka. So if you have two regions, the easiest setup to do is to have a collector in both regions. That collector will write to Kafka. You'll probably need a Kafka cluster in each region, which we already had. That helped a lot. You write that to a different queue and use the replicator in the east region, or whichever is your primary, to sync that data from west to east and merge that in a topic that contains both regions. With that configured, you can use the Jaeger ingester to consume all the data from that topic, which contains everything, and writes it to your data store. The replicator in question is, we use Confluent message replicator. There's various options, even one from Uber, so you can look up the various trade-offs on GitHub. There's still a problem with the previous approach, is that if we were to lose east, we would lose access to our trace even in west, which is not ideal if you're trying to survive a regional outage. To achieve a multi-region that can survive that, you'll have to use, well, in this case, 2 data stores, a few more replication, and that's pretty much it. You set up both collector to write to a topic. You replicate from east to west and from west to east. Configure another ingester to write to another data store. And now you have all the data from both regions in both regions. That's not all you can do with Kafka replication. You could replicate from an isolated network to a non-isolated network with a bridge, or even do the same thing, but with multi-region with isolated network. The graph won't be explained today, but it's all available in my slides. So let's talk about scaling now. There wasn't much documentation on the scaling when I submitted the talk. Now there's a little bit more. So my main advice was to start small. There's the remote control sampler that's available, and it lets you control how much data you ingest from your various clients, which lets you control when to scale and not having it forced by your client joining your cluster. This is the blog post I was referring to from one of the maintainers. I've added in this slide all the various queues, the bounded queues that are in the architecture. There is one from the Jaeger agent to the collector, even one from the Jaeger client to the agent. Pretty much everywhere there's a queue. Those queues are designed to prevent Jaeger from crashing if there's too much load. It will start dropping data instead of it. And they can all be configured with the various flag here. You can watch the metrics to know when to scale and what to scale. In the collector on the left, you see the metrics that would increase if your data store can keep up. In the middle, you see the queue I was referring to. If you see that drop metric increase, that's probably because you don't have a queue big enough. So you can either increase it, but it will cost a bit more memory, or you can add more collector to handle that load more easily. And look at the logs. There's various reasons and various times we've seen problems that were not part of any metrics. Scaling the agent is very similar. It's well described in the blog post, but basically you have one to see if the collector can catch up or if your agent is dropping data because it can catch up by itself. There's also logs. Even if it's a tracing talks, logs are still useful in this case to debug. And we've skipped pretty much everything that was, well, we skipped a lot of things that were hard, how to scale Elasticsearch, how to scale Cassandra, Kafka, or even Kubernetes. There's good talk about that on the web, and even good talks right here for Kubernetes. So, and to close the scaling section, I wanted to show what is our current infrastructure. I've shown Elasticsearch on the left and the Jaeger collector on the right. We run only 4 pods right now. It used to be just 2. We've increased it recently because we're forecasting a bigger adoption soon. The Elasticsearch is the important part where we have very fast hard drive, which makes I/O incredibly fast and not a bottleneck. And now let's talk about extending Jaeger because it might not fit your needs right now, but there's still a lot to do. The biggest feature I've seen in GitHub about extension point in Jaeger was to add a storage plugin. It has been merged since 1.12, which was released this week, if I recall correctly. So it's now possible to add DynamoDB, Bigtable, InfluxDB, or any other database instead of using Elasticsearch or Cassandra. If you want to protect your Jaeger UI, it's been requested a few times. Right now, there's no such feature, but you can front it with Keycloak. This blog post will explain you and walk you through exactly how to do that. But that basically had an SSO in front of it. What we used extensively at Ticketmaster was UI customization. You can add custom menus in Jaeger, which includes links to our internal documentation or Slack. You can add tags on you can add links on your tags. So we use that to link with our inventory tool to find the Slack channel of the team, to find the on-call information of the team that's having a problem, or even the source code. But you can link anything, any links. You could link directly to the AWS console with this templating, or to your Splunk logs, your ELK log with those right here. the possibilities are endless with that, and it's been a feature that's been added from the community, so it's very great to see people having great ideas like that. The last one, well, not the last one, but another one is a concept of processor inside Kubernetes, inside Jaeger. It's not exposed right now, but there's an open feature for it. There's 4 types of processor. The first one is the preprocessor. It handles batch of message. You could normalize the data, extract metrics on it with it. The second one being the filter span. It will allow you to build a whitelist or blacklist of services. You could enforce mandatory tag, yeah. Enforcing remote sampler would be a good one, but it's not possible right now. Third one is being the span sanitizer. That's what you would use to normalize tag or even remove sensitive data before replicating that across. The last one is the Presafe processor. It gives me a hard time because I don't know what you would do with that you can't with the 3 previous one. But if you have an idea, please comment on GitHub. So don't fork Jaeger. If you feel like there's something missing, you can even import the code of Jaeger, create your own main, and customize it to your need. And even and once that's done and it's fully baked in, you can contribute back instead of doing a hard fork. It will save you time because catching up with a big repo can be hard, and it's also much easier. The last one is to do analytics on the trace. So if you have other trace flowing through Kafka, you can analyze them to build SLA chart or dependency map that are much more complex. You could, just like Uber does, build trace quality tool or latency histogram. So that was the agenda. Thanks everyone for listening. I don't think we have time for questions, but I'll be staying right here, or if you want, continue to chat.